Hey everyone, welcome to Tutort Academy. So my name is Chirag Vaishnav and this video we are going to solve distinct subsequence. So it is one more hard lead code problem. So it's basically the continuation of the DP on strings that we have been solving. A similar kind of pattern has been observed, a similar kind of thing has been observed. So what you have to do, you have to solve these problems. The number of problems that I have explained, you have to solve them and consider them, learn from them, visualize from them, try to get things out of them, right? And I'm definitely sure that after this it will get clear. After you have seen all the videos of the DP on string that I have created, mostly of them are hard on lead code problems, right? So you will definitely learn a lot of things out of it, right? So let me just first give you a brief about this video. So what we will be doing is, first we will be having the problem statement, learning about the problem statement, then we'll be looking after the logic that we'll be building, and then after that we'll be looking after the code, right? So let's get started without further ado, right? So distinct subsequence. So given two strings s and t, return the number of distinct subsequence of s which equals t, right? So what you have to do, basically you have to find the distinct subsequence of s which equals t. So you have to make t out of s, right, if that's possible. So a string subsequence is a new string formed by the original string by deleting some of the character without disturbing the remaining character relative positions ACE, ABCDE, AEC. So we have discussed, we have done longest common subsequence question. If you remember, if you haven't watched it out, link will be in the description or in the iTab above. Do check it out. So in the longest common subsequence, what we did was basically that we have tried, okay, what we can do, we can just we have two options, either to take it or not take it, right? If they're equal, then go for the next, and if they're not equal, you have to either take it or not take it. So we were having choices. In this question also we are having the choices. So what you have to do, you have to find the number of subsequence that are possible to form a t out of s, right? And the test case can be generated in the answer fits on 32-bit signed integer. So that's the basic limit that we have been provided with, right? So suppose RABBIT is the S and T is RABBIT, right? So in this we are having three options by which we can make rabbit out of it, right? So you can see that what you have to do, you have to make exact T. So T should be exact. So in this case we are having that either we can take one B at a time, right? There are three B options. We can lose one B and we'll be having the final rabbit. So there will be three options, okay? Leave this, and finally we will be having a rabbit, right? So I hope that it's not clear till now, right? So let's just open this. Let me take a new file and let me just present it, right? So I was having RABBBIT and RABBIT. So out of this I have to form this, right? So suppose this is S, this is T, and what you have to do, you have to find subsequence, you have to find number of subsequence of S that will make T, right? So in this, if I use this B, if I left this B, then again I'm able to form a rabbit. If I left this B, then still I'm again able to form the rabbit. And if I leave this B, still I'm able to form the rabbit. So this is how it will work. Now how we will calculate it, because with the human brain, with the normal observation, okay, we can say, but how to make it understand to the computer, how to make an algorithm depending on that, right? So again we will be following the same thing that we have been following lately a lot, DP on strings. So there will be options, there will be possibilities that we have to deal out of it, right? So the thing that we have to keep in mind is, okay, if that if the element, if it is equal, then okay, I don't have any problem out of it, right? So it will not make a case for me, right? So let me just explain it in this way. RABBBIT and RABBIT, right? Suppose it's rabbits here, right? So now they always, while traversing a string and while forming the subsequence quotient, make sure that what we will be doing is we will be starting from the last index, right? Last index we will be calculating, and at each point in the string we are obviously having two options while comparing two strings, either they are equal or either they are not equal. So we have to see that what we have to do in the case of equal, what we have to do in not in the case of equal. So s and t are not equal, right? S and t are, suppose I'm having here, so s and t are not equal. So in that case what you have to do, you have to do, so what we have to do basically, we have to convert s to t. You have to convert s to t. In t I cannot do any operations, right? In t I cannot do any operations, and in order to find t, I will take t if and only if the element in s is equal to it, right? So if the element in s is not equal to it, so let's say the length of s is n and the length of t is m. So and the function will be, let's say, sub. So won't it be, in the case of not equal, won't it be, I will not take s, n minus 1, and I will not reduce m, or I will not let's move back to I. Why? Because t is not being used yet. So it can be used, it cannot be used. No, there's no question in that, because if we are not having them equal, there's no use of taking s now. S is useless for us because we need exact t. We don't need an anagram for it, right? So if it's not equal, then this will be the case. What we will be doing, we will be calling for n minus 1, and m will not change. Now second is the case of equal. So if it is equal, okay, I can take it, right? But there will be one more case. If they are equal, okay, we can take it, but there exists one more case, that what if I don't take it? Because at each instant you are having two options, either take it or not take it. Because if they are not same, obviously you will not take it because it's not fruitful for us. But if it's same, then there exists two cases, either you will take it or not. Why? Let me explain you. Suppose in this case I took it, in this case I took it, in this case, right? In this case, in the B case, right? Now if I take it, I can go to this. If I take it, I can go to this, and further I can move it, right? But in this case, suppose if I skip it, right? But if I will only use this case, right? If I will only use this case, and if I will not use this case, my answer will be 2. Right? Oh, my answer will be 1, obviously, right? It will not be 3. Why? It will not be 3 because I'm not checking if I'm leaving something or not. So because in this case I'm checking if I take this, can I make it, or if I leave this, can I make it, right? Because if you leave this also you can make it, if you take this also you can make it. Now I'm thinking that we are going to the point, because the thing is, if it's not same, then you have to leave, obviously leave it, right? But if it's same, then you have two options, either take it or leave it. Sorry. And in that you have to check if, okay, if I take it, can I go further? If I take it, can I go further? Okay, yes. If I take it, okay, there will be answer. If I leave it, okay, there will be answer as well. So this is the thing that you have to keep in mind. So this will be the base cases. That, okay, if it's same, then you have to check for both. If it's not same, then you have to for sure leave. Now what will be the base cases? The base cases, as we are starting from the end, suppose I for this and j for this. If we have reached to end of the j, this simply means, okay, there exists a pattern. If we reach end of I, and we haven't reached end of j, this simply means, okay, you have to return false, the path is not correct, you have not formed the t, right? So this is the basic thing that we have to do in this question. Now let's head over to the question part. Okay, so here we are. So in the, you can see that what we have done, we have made a dp, we have resized it to size of like n plus 2d dp, right? And after that, what we have done, we have call this function on a minus 1 b minus 1. Why? Because we are starting from the end. Now what was the base cases? If j is for pattern, j is for the t, if pattern becomes empty, this simply means okay, we have like traversed whole thing and we have got to the final answer, then you have to return 1. And if a string is minus 1, if we have reached the end of the string and we have not reached the end of the pattern, if we have reached the end of the pattern, okay, then you have to return 1, okay, you have completed successfully. If you haven't, then you have to return 0, that no, you haven't. Now it's the basic DP memorization technique. If it's not minus 1, then you have to return the DP of I, means it is previously calculated. Else if it's not calculated, then the thing is that two cases that we have discussed. If the characters are not equal, then obviously you have to skip it, I minus 1j. Else if they are equal, then you have to check for both. Either you will take it I minus 1 j minus 1 or leave it I minus 1 j and add both of them and return dp of ij. So this will calculate your answer and at the end you will get to the final answer. So this was it for this question. I hope you like the solution. So if you like this video, do give a thumbs up, subscribe to this channel, and if you're having any doubt regarding anything, do ask in the comment section. I will for sure answer it. So thanks for watching.